Okay, and this was done when Android was still in its infancy, like at the beginning of Android, it was really hard to get it going. Okay, next. All right, so we basically what we got is the local sonic cues serve as a scaffold, okay, for decision making, okay, and the mechanism is the structure. So let's show the demo so that they get started. Okay, this is the first prototype.
Anyway, it's fine.
That's okay.
That's okay.
We'll watch it.
No.
Yes.
One minute.
One, yeah. One minute, 7 seconds.
That's fine.
No? Tricky.
It's clicked. No, it's frozen.
Yeah. What about that? Ah, it's frozen. Oh, okay. Okay, so basically what we did here is started using this prototype. We used we use it in shopping malls, okay? We use it also in the street, okay? With people doing mixing in real time in the street. This is the first design, pretty simple. Just getting the sound out of the system was already kind of a tricky thing, and then we improved it. The next iteration, we improved the design and came up with the stripe concept, which is here. So the user will actually select a bunch of sounds, and then these will be available. Okay, and as you can see, you can have several sounds. And this is automatically mixed. It's seen as a mix. So the mix can include so that's okay, that's fine. So so this stuff worked well, but it had the limitation that you need actually touch the device. Now what Tony was showing and what we can do with today's technology is work on proximity. So we could actually expand this same idea and apply it to dynamic usage of interaction, okay, and portal. All right, so now the second part. Maybe we play the video first and then. You want to start explaining?
Yeah. So for the second part, we have this dynamic drop, which is a kind of a
post-estimation based drum tool where we play the drum machine and the drum machine moves along with you, right? Because it tracks you. So if we start from the very beginning, we started this research from last year, I guess, and yeah. So in the first thing, we had 3 prototypes of the drum machine. First initial phase, it was a very simple drum where the first prototype was very simple drum where we just put 2 images of instrument and we tried to play that. So but there were many problems with the drum. So we started working on the drum, and then we had this prototype 2, and we will discuss about the prototype 2. So basically, the drum had 4 individual instruments. One is the kick, snare, hi-hat, cymbal in the latest stage now, and it has the ability to take our body informations and play along with that. So if you go to the next slide, we can see this is the system architecture of the drum. So we have the laptop camera, the information is just, it's from just a laptop camera, and then we have the post estimation algorithm running behind the deep learning model, which gives the information to the dynamic drum machine. The dynamic drum machine then tries to get the data and align or map the data according to the outputs, and also give a visual output and an audio feedback to the user so that he knows what is playing. So the machine, this whole system can be run in any machine. Basically, you don't need a GPU, it runs on the CPU. So anybody can run just a laptop camera. So it's very simple to learn. And we have some DAW running behind for the sounds. We can also use samples if you want, but sample takes time in trading. So we use the DAW, which is very fast because of latency problem. So everything happens in real time. For getting 2 information, one is the note information and the velocity, that how hard the drummer hits it. So we had this cue replacement technique where we stored the information of few frames of the motion, or where the value is calculated by the difference between 2 frames, 2 video frames, and the more the displacement, that means we have a better velocity or more velocity. So in this way, we calculated the velocity of how hard the person hits the drum, and then we have the index finger as the triggering point. Whenever the index finger reaches the point or inside the drum region, it triggers the sound, and the MIDI parameter is used for triggering. So in the prototype, we tried to understand the whole system using a drummer. So there was a guy who was a professional drummer. We told him to explore the drum without giving any information to him. So the first session was a exploration session where he was trying to figure out what the drum was like, because we didn't give any idea about what is the special. We said that the drum is just like so he invested some time to figure it out, and after some time he started learning it, and maybe 10-15 minutes he was kind of he figured out own ways of improvising music and stuff. Then we give him the later challenges to play a simple beat, like just tap 2 hands in a rhythm, and he was able to do that. Next we gave him some harder tasks to play some complex pattern in this type of drum, and we tried to measure the tempo or the velocity or the tempo or the speed at which he was trying to play. So we figured out that there was some there are some velocity, like the tempo like 60 to 125 was achievable. Beyond that, it was not possible because of the latency problem, the processing time for for the deep learning network, because it's running on CPU, as well as the haptic feedback between the camera and the player. So on the third prototype, what we did was we had a couple of non-musician participants participating in the experiment, and then we tried them to play an advanced version of the drum, which was more stable, much better, with 4 different instruments like the hi-hat, kick, cymbal, and snare. So, and also we told them to play with their friends together. So we had a server client architecture in that, and they were collaborating and playing with each other. We also saw that there are many kind of latency problems because there is a network involved where the two drums or two people were playing. There was kind of processing time of the algorithms depending on different laptops. But more or less they were efficient enough and they were able to produce a rhythm between both of them. We will see that in the demo. And the last thing was really interesting at the last talk that the people we suddenly told them just close your eyes and play. Okay, they were more comfortable to close their eyes and play rather than looking at them, getting the visual feedback because they can figure it out. Where is the position? But when they were looking at the camera, it was taking some time. It was they're not because they are not musicians. Can't handle the brain, can't handle that kind of latency. So yeah, it was a good observation. And then we have this demo. Just so over here, he doesn't have any body landmark, so he doesn't know that what is going on, how it is tracking. He doesn't have any idea. And the two side boxes were the thing by which he can put the drum kit in any positions. So over here now he has some idea that how things are working. In this one, he can position the drum machine according to his wish and play. So it can be played by anyone, by any part of the world. And this is the way it moves along with my body. Whenever I moves. Also see this if I come closer or go far away. So this was the non-musicians try to play this drum. Okay, and the rest part, I think Damon will explain for the next.
Can you?
Yeah.
Okay, so these two examples point to the possibility of a more general paradigm for interacting with impact sounds. Okay, so the idea we came up is calling this banking interaction paradigm, in which we have a moment of preparation, which includes several operations and several issues. The moment of motion tracking, in which the system actually is detecting the motion of the hand or the motion of the body, and the moment of collision, in which actually it serves to start renderization process, in which we will have some synthesis or some processing or some simple playback if the hardware doesn't let you do more than that. So this will be sort of the general notion. So in particularly, we will be talking about 3 stages: preparation, motion tracking, and event visualization. Okay, which will include setup, installation, configuration, and motion tracking acquisition through a platform-specific solutions, and then renderization will include synthesis, processing, or playback, depending on the case. And next, and the difference in this approach, in targeting specifically impact sounds and dealing with interaction from a specific class of sounds, is that we are putting timbre at the center of the proposal, and we are forgetting about what device, what instrument, whatever, how you do it. Okay, we come up with the idea that actually timbre will go first. Okay, so this approach supports simple sonic rendering like playback or something, but also it could include complex processes of things up to certain limits. And there is also the issue of the synchronous visual feedback, which Fadila was talking about, which maybe it's necessary at some stages but not necessarily in a way that we understand music making as chamber music, okay? Everybody playing at the same time simultaneously. That's not what we are proposing, okay? So last one. Specific ideas that we take from this project. Consistent model, cross-model interaction mechanisms, okay, that we need to keep. We constrain the choices to a specific timbre class, in this case, banging or impact sounds, okay, and implies a change of perspective. We start from the sounds, and then we go back to the interaction mechanisms, rather than the opposite way, okay? So, first choose your name, then find a hammer. So, these are some of the publications that we did, particularly I refer to this book here, and there is another one that came up last year, okay, Routledge, and if you want more information. So that's it. Thank you.
Any questions for David?
And if Duarte is online or if he's here, please let us know. We can do the chat, the streaming text, so we know. Any questions for David?
Okay,
you've got them, David.
Yeah.
Both of you, sorry. Okay, Bruno. Well, Bruno said, and I just want to say this has been a really nice session for me. I had a present for Bruno the other day, and then a present for David. Be very nice the other day, and also